So today will be our review sections, and the main goal today is try to connect the concept introduced in the chapter 8, 9, 10, 11, 12, and try to connect them together and help you to build a broader and bigger pictures to understand this concept. And I hope that this one can help you to prepare for the final exam. However, you are expected to watch all the previous video lectures, and as I mentioned in the email, in the final exam, especially the conceptual question will heavily depend on the video lecture itself. So before we start our conversation today, I would like to share the verses with you. This is in the Philippians chapter 4, verses 4 to 7. Rejoice in the Lord always. Again, I will say, rejoice. Let your reasonableness be known to everyone. The Lord is at hand. Do not be anxious about anything, but in everything by prayer and supplication with thanksgiving, let your request be made known to God, and the peace of God, which surpasses all understanding, will guard your hearts and your minds in Christ Jesus. I know that when we move all the courses online, this is not an easy transition for some of you. So when I pray for you, this is the verse I want to share with you and encourage you. Even when we meet the difficult situation, we still bring all our needs and prayer in front of God and believe that God will guide us. I also want to share these verses particularly with the students who are going to graduate in this summer. I know that we are not going to have the traditional graduation ceremony, but I would like to share these verses with you as encouragement in the future, no matter you are applying for a job or applying for the graduate school. So even in this kind of pandemic period of time, it is a difficult situation, but still we should rely on God and rejoice inside of God and believe that God will guide us all the way. So now let's start the discussion. So I will try to connect all the concept to you, and the key word you will keep hearing I say is the electrons. So electron is a particle carry the charge, and we know that the charge have two different signs, positive and negative. And electron plays a so important role in the following discussion is that the electron carry the charge, they will have a force in between. And people find out if you carry the same sign of the charge, they don't like each other, so it is a repulsive force. If they carry the opposite sign of the charge, they will attract each other. So this is the starting point. So we know there are some particles carry the charge, and there are some interaction, which is a force in between them. So now, when we try to study the property of the material, the electron plays a very crucial role. So we have demonstrated this one to you is that, so when you try to charge the rod can use to be attract neutral object. So why the neutral object can be attracted? It is the phenomenon so-called the polarization. So this is the molecule within the paper. So the paper is made of some atoms, which is neutral. But when the charged rod is approaching to the material, the paper will be polarized. You can see that the paper is still neutral, but because of the movement of the electrons, so now this end will be negative charge, and the further end will be positive charge. And because of the force difference, now the neutral object could be attracted. So you can see that the polarization is simply due to the movement of the electrons within the material. Even itself eventually is still a neutral object. And why the electron is moving to this end and the positive charge is moving toward to the further end? It is because that the different sign of the charge attract each other and the same sign of the charge repel each other. So this is a very important way to understand the property of different material. Then let's study that the atom inside, which is the thing we introduced in the chapter 12, is a neutral object, which means the net charge is 0. What does that mean? It means that the number of the protons in the nucleus is the same as the number of electrons. So these two numbers should be the same, so the charge are cancelled out. So atom is a neutral object. So each of the particle here is an atom. And now, the so-called electric conductivity is that we have some electron in the outer layer of the metals. So do you remember in the chapter 12, we introduced you that the shells model? So there in the outer layer, there are some electrons. If they are loosely bound, which means the interaction force between the electron to the nucleus is completely weak, such that they can move more freely and the electron can behave as a conductivity of the metal of the materials. So depending on how strong the outer electron is bounded, it determines the electric conductivity of the material. So I hope now you understand why in the chapter 12 I mentioned that the electrons plays a so important role to determine the chemistry and the physics properties. And now, based on the movement of the electrons, we can define two different kinds of materials. One is the conductors and one is insulators. So the conductors is a material that the electron can move freely, which is an easy flow in the material, which means that the outermost electrons are loosely bound. However, for the insulator, the outer electrons are tightly bounded, so they cannot move easily. So therefore, the electron cannot move from one end to the other end within the material, so the electricity cannot be conducted. Okay, so did you see that now electron played a so crucial role to understand the physics? And now we know that no matter they are the same sign or the opposite sign of the charge, they have the force between them. And this force is described by the Coulomb's law. So what is the Coulomb's law? It is proportional to the product of the two charges. So Q1 and Q2 are the two charges I show you here in the picture here. So you have Q1, Q2, Q1, Q2. And depending on the sign of charge, you put positive or negative here. So it is proportional to the product of the charges, but inversely proportional to the square of the distance. I find out that the students, some of you, always forgot about the square sign here. Okay, so even it is trivial, but let me remind you again. The square means an important thing. So if the distance is double, then the force will be reduced, eventually become 1/4 of the original value. Okay, so don't forget about the square here. So the behavior is very similar to the gravitational force. And just a reminder to you, because the final exam is an open book exam, so I'm not going to provide you an equation sheet anymore. So you have to prepare the equation sheet yourself, or you can simply just check your notes or the textbook. So based on the Coulomb's law, now if we consider different combination of the charge, if they have the same sign, then they will repel each other. So you see now the directions of the electric force is determined. And the Coulomb's law here also lets you know the magnitude of the force. So the sign of the charge let you know the direction already. If they are opposite, they will attract each other. So Coulomb's force, which is the electric force, is a vectors. What is a vectors? This is very important concept. It is a magnitude plus the information of the directions. Also, since you have two particles, so the force acting on the Q2 and the force acting on Q1 supposedly should be the same in the magnitude but opposite in directions. So what does that mean? This is nothing but just the Newton's third law. Action and reactions. So Q2 try to act on Q1. Simultaneously, Q1 act on Q2 in the same magnitude of the force. And now we try to define the so-called concept of the electric field. What is the electric field? It is the electric force per charge. So it is different from the electric force. And we find out we can try to visualize the concept of the electric field in terms of the field lines. And the direction of the field line is pointed outward in terms of arrow here. So if it is a positive charge, then the electric field line is always outward. If it is a negative charge, the electric field line is always inward. And if you have a denser electric field lines, it means the electric field is stronger. And here the density is weaker, it's smaller, so the electric field is weaker. So based on the electric field, you can know the directions and the magnitude. So this is a very important concept. So in the conceptual quiz, I may simply just remove the sign of the charge and asking you, can you determine the sign of the charge based on the direction of the magnetic field lines? And now, when you have the nucleus with the positive charge at the center, and you have the positive charge approaching to it. So what happens is that they don't like each other, yeah? So when you try to move the positive charge toward to the nucleus, you have to do the work. So there's a repulsive force, yeah? So you have to fight against the repulsive force and try to push the positive charge toward to the nucleus here. So the work you did will be converted in terms of the electric potential energy. But this concept is exactly the same thing we learned in the chapter 4, the gravitational potential energy. And a lot of people forget about that the energy will be stored when you push the positive charge or even the negative charge toward to this nucleus. So when you are pushing them toward to the center, you have to do the work. So the work was stored as electric potential energy. But when you remove your hand, then because of the repulsive force, the positive charge will try to receding away from the positive charge at the center. Now the electric potential energy will be converted to the kinetic energy. So the concept you learned before can be applied here. So now you can understand why there is an electric potential energy stored and eventually will be released as a kinetic energy. Now we define a quantity which is different from the electric potential energy, which is electric potential. So electric potential is the electric potential energy per charge. So this is the equation for that. So electric potential means just give you a sense of feeling about the direction of motion of the charged particles. So it can behave as source to provide the current or the charge. So here it is a analogies to understand what is the voltage source. So when you have the water pump here, and this is a pipe, a valve is the way to determine how much the water can flow through. So this pump actually is the concept of the voltage source. They can try to force the water to move. But when they move in the pipe, depending on the valve, they can determine how fast the water can flow through. So the same thing, when you try to build a circuit, you have to provide a voltage difference, which is a source, and the current will start to flow. And when they flow in the circuit, they will meet some resistance. So now let's try to go back and refresh the three important concepts: the voltage source, current, and resistance. So the voltage source is the way to provide a potential difference such that the current can move and flow. So the electric current is simply the movement of the charge due to the voltage difference. So they always move from the bigger voltage end to the lower voltage end. This is always the directions. And when we define the electric current, we always define that this is the movement of the positive charge. Always a movement of the positive charge. And when they move from the higher end of the voltage, they will release the energy. And eventually when they go back to the lower voltage end, all the energy will be released in the device, so-called the resistors. So now let's talk about the resistor. So resistance is the device try to against the movement of the current. So the value of the resistance depend on the geometric property. So the thin wires will resist the electric current more than the thicker one. Okay, so you can think about it. The more thinner the resistance it is, the less of the water can flow through. Yeah, so the same principles. And the thicker, the smaller the resistance, and the longer the wires also will make the resistance bigger. Okay, the longer one of the resistance, it will make the resistance bigger.